Okay, good morning, everyone. I hope all is well. Really appreciate you all joining us for our spray characterization. Very brief introductory on what we can look at for spray characterization and how it really impacts you and your processes. I've got Dr. Kyle Bay joining me as well. He and I have had some fun adventures together, loads of projects that we've embarked on, and we look forward to discussing a few pieces of technology and where the opportunities might lie. Go ahead, Mary. So what we're looking at is spray characterization. And while we think that a spray is just a spray, there's a lot that goes into it. And what you'll notice as we go from left to right, you have various formations. We have the dribble aspect where you have a very low pressure, low flow. And then you have this in-between stage where it's like the onion stage. And you can see it's starting to slowly develop, but not quite get there. And then from there, we go into the tulip stage. And from that tulip stage, we go to a fully developed spray. Now, what's important is for us to understand when we're at that dribble rotation jet stage that sometimes these processes have a delta P that we're working on. And if the line pressure that you're injecting into increases slightly, this might be what you're getting on the inside of your process. And without being able to see how that spray is performing, we may not have any optics and we might not be getting that fully developed spray pattern. And Dr. Kyle Bade, I'd like for you to speak a bit too on that fully developed spray and what we see in the mechanics behind that.
Right. Good morning or good afternoon, everybody. Thanks, Justin. So when we have a fully developed spray, that means we have a well-atomized spray, that the spray is distributing properly, typically fairly uniform or in the shape or pattern that we're intending. As the spray pattern goes up, the greater energy in the spray allows the liquid to break up into droplets, as you can see in the lower half of that final fully developed spray pattern. So before that point, what you can see is larger droplets, potentially distribution of the spray pattern that isn't going to be in the shape or the distribution that we're aiming for, we're after.
Yeah, thanks, Kyle. And so that fully developed spray is typically what our clients are looking for. And what we're going to start seeing is that's very important for us to understand what's happening in our process besides just pressures and flows. Next slide. So spray characterization, we have a number of pieces that we look at in the lab. So we look at drop size, we look at spray pattern and shape, our spray angle, velocity, and spray impact. And while all of these are critically important, in the field, we see that we're only measuring pressures and flows typically. And we're going to be able to get a little bit more detail with some of the technologies that we've developed. Next slide. So along with spray characterization, there's also some liquid environmental factors that are critically important for various applications. One of which is specific gravity. We need to understand the density of that spray and how that impacts not only your pumps, but also how it impacts your spray characteristics. Another piece is the viscosity. Viscosity is important to understand the amount of energy it takes to move that liquid. And then the next piece, of course, is surface tension. And then we have temperature and abrasion and corrosion. And Dr. Kyle, if you could speak a little bit about that relationship between viscosity and surface tension and why that's important to understand that distinction.
Right. Understanding how a spray is developing in terms of the characteristics on the previous slide and based on the material properties or rheology of the material is going to be very important. Drop size in particular is going to dictate how well distributed the spray is, but characteristics such as small droplets will coat a surface more uniformly If you're spraying onto a conveyor, maybe in the paper industry, that would have a very important effect of how uniformly or non-uniformly you're coating your substrate. In addition, smaller droplets are going to evaporate and interact in the environment more quickly. And so in any gas processing or gas conditioning applications, having a smaller droplet is going to mean that the surface area of that droplet is greater and you have less volume contained inside the droplet that's not going to interact with the material. So as the viscosity is increased, that is going to resist the flow through the nozzle. And so you're going to end up with larger droplets because the material itself can't flow quickly and break up as it leaves the nozzle. Surface tension often has a similar effect where it resists the breakup of the droplets. However, surface tension is going to be a little bit different in that the viscosity will sort of have a slow effect on changing the droplet size or the spray characteristics, whereas surface tension we typically find has a more of a cutoff level where once you reach a certain pressure, for example, with a flat spray, you can start to see droplets not atomizing well much at all, and then all of a sudden bursting into smaller droplets. So the effects of surface tension versus viscosity tend in the same direction. Higher surface tension, higher viscosity lead to larger droplets typically, but the end result on the spray atomization can be quite different.
Yeah, Kyle, and what you described, and we see this in applications, numerous applications, is that inflection point, right? And that difference between viscosity. Oftentimes, oh, the viscosity makes a big difference, which it does, but also that surface tension, if it decreases as well, that enhances the atomization up to that inflection point. And it's important to understand that distinction. And another piece
Absolutely.
in the gas processing industry is that abrasion and corrosion. If you notice down in that far right-hand corner, you see some droplets that are perhaps larger. And if you're flowing, let's say 500 gallons a minute of flow, those big droplets could have an abrasive effect on your downstream piping. Whereas if we can get the droplets more in that middle range, perhaps you can get a lot more out of your rheology and also tear up your piping a lot less, be more kind to it. And that's really the important piece. What we find with spray, the more we dive into it, the more detailed and smaller we go, the larger it actually becomes. Next slide. So how can you leverage spray characterization, and how do we get from what we can do in the lab and into your hands? One piece is the process optimization piece. And these small tweaks that we find, whether it be chemical refinery plants, perhaps it's in the food industry, paper industry, can lead to very, very large results and large gains. Again, the more detailed, the more measurements that we can capture, the more opportunity we have for improvement. And while flows and pressures are a good baseline, we find that there's nuance behind that flow and pressure, and there's another layer that we're able to achieve that can bring some powerful insights. Another aspect for that spray characterization is the enhanced sustainability initiatives. Many companies are looking to be as fruitful as they can with all the resources they've been given. And spraying systems vision is to make sure that every drop counts. That's a very simple vision, but one that leads to that sustainability piece and ensuring that you have the right droplet size, doing the right things at the right time. Another piece for characterization is it drives innovation. Again, it opens up some questions that may not have typically been asked. And when new questions are asked, new answers come online, which from that innovation leads to competitive advantages. Again, what gets measured is what improves. So if we're able to measure a little bit more out in the field, out in the processes, then that lends itself to competitive advantages as well. Next slide. So again, we're looking at the spray formation stages and why that's important. You're increasing your flows, you're decreasing your flows, and you can see how that drop or that formation changes. And that change can have huge implications for your process. And Dr. Kyle, if you could kind of speak to what's the next iteration outside of just measuring pressures and flows, and what's been developed in the lab and how this can be leveraged in the future.
Right. So we've been doing spray characterization and detailed characterization for decades in spraying systems. We use many of the most popular commercial instruments. Many of these instruments cost up $100,000, $250,000. So we've made significant investments in our facilities to bring those tools to our customers so that we can spray smarter, achieve solutions with less material, be efficient, be green, all these things. Now, taking this technology and like the title of the talk here today, and taking that out of the lab, right, and into your hands is where we're going to move on to next, which is some exciting developments we've put together in the area of spray characterization and detailed spray characterization, where we're doing much more than just pressure and flow, which is a great place to start, but going further allows further optimization, refinement of the solutions.
Thanks, Kyle. And that important piece that we're looking at on that spray scan and that patented technology. And Mary, you can go ahead and play this video. This is essentially what you would be able to have access to at your facilities to assess spray health and to really get an understanding of what's happening. You know, I'm starting to see plants and processes and facilities are being analogous to biological systems, meaning that they're constantly moving, constantly adapting. And just because we weren't able to see such granularity in the past doesn't mean it wasn't changing. And now we're able to get some insights as to what's happening. And you can see just with some very simple pieces of hardware that we're able to really get a good quantitative look at this spray and create different distributions. We can see the different intensities, and we can visualize optically what's happening with that spray in particular. And what's nice is we can export this data and we can look at it from a basal standpoint. And Kyle, can you speak a little bit to the mechanics of what's going on here and what we're seeing?
Yeah, absolutely. So this particular instrument is something we've developed, and like Justin said, it's a patented design with proprietary software. And what it allows a user to do for a fraction of the cost and a fraction of the time is to use a laser sheet, and as the spray passes through that sheet, it's illuminated. And then we take an image or a video of that spray, and we can, in less than a minute, evaluate the spray distribution in 2D, or as you see here in 1D, depending on if you're trying to coat or distribute in a tower, or if you're trying to coat onto a surface where the 1D distribution might be more important with a conveyor as application. So in a matter of a minute, you take this thing out of the box and you can really be evaluating sprays in great detail.
Yeah, that's pretty important. You know, oftentimes in various processes, we see, let's say it's at a plant or for a turnaround, folks will take out a nozzle and they'll say, oh, look at that, it sprays. You know, visually, the human eye has difficulty discerning, even with the flow rates increasing more than 30%. So imagine how much more wear and tear on that one nozzle you're going to create for your up and downstream processes, upstream being the pumps, downstream being the flow rates that might be happening along with the larger drop sizes, increased impingement, et cetera. But imagine having a tool such as this in the field to where we can say, hey, perhaps we're only 5% over spray capacity. This nozzle is technically good, but whenever we can conceptualize it and characterize it, then it's way out of line, very sensitive processes. Rather than sticking that nozzle back in, which might cost 50 to $100, it can throw up a trigger to say, hey, perhaps we need to reassess this. And the cost implications are simple, rather than plugging it back in and going another 5 years on that turnaround.
Yeah, and being able to do this right, either online or just to the side offline, is a huge advantage. You know, we don't have to try to replicate the process or the environment in the lab as we typically do.
Yeah, absolutely. Next slide. So what's nice here is we have some cool technology as well, being able to virtually overlap and look at these sprays, not only from a singular spray, but numerous sprays, and optimizing that distribution for what you have in the field. Rather than taking lab data, we can understand what's happening at the source, or more accurately, you can. And let's say you have a basic header, you need to get all kinds of neat coverage regimes. You can see here we have some peaks and valleys. Operationally, that costs money. So let's look at enhancing this with that software. So we're optimizing the layout, got some cool algos running in the background. And now you notice the peaks and valleys are normalized. And those peaks and valleys can have some pretty heavy implications. Imagine if we're spraying, let's say, bread, and we have these peaks and valleys, you have quality control issues. Well, suddenly, now we can be more fruitful with the rheology we have, tightening up those distributions. And Kyle, can you speak a bit too to even distribution towers or trays that we would see, in a circular orientation? How could that be a benefit for somebody in the processing industry?
Absolutely. You have a given flow rate that you need to put through a tower, for example, and then where do you position these nozzles to adequately cover the entire environment, use the entire tower effectively, right? You don't want to have dead zones. You also don't want to be hitting the walls where you have potentially buildup of material or at least wasted material that's not interacting with the gas stream. So having a good idea of where that spray is going to be going and where to place those nozzles ahead of time is what this software allows you to do.
Yeah, and Kyle too, what's I think important, not only the geometric, right, the theoretical spray coverage, we can get a little bit more granularity on that too, and also be able to see what impact gravity has on how that spray pattern is being formed and contracts or expands, and that could change based off of your pressure drop versus what's sprayed at the lab. Oftentimes, when we're working, we have 40 psi. And this is what the spray looks like. We hand that to the customer. Perhaps they have 40 psi at the gauge, but the actual spray that they might have or the pressure available might only be 20 psi. So we're making baseline assumptions, whereas here we can really see what's happening at the source.
Right. Between the two tools, we can measure on site, evaluate with the material that's actually being sprayed, or you can, right? We don't have to do this anymore. And then from that, after measuring that real spray, you can then optimize that real distribution.
Yeah, and I like that important distinction you made, Kyle, is we can also get baseline data, right? You can say, hey, this is a healthy spray with a quick scan. And instead of waiting, and assessing and visually looking at it, you can say, okay, maybe in 3 months, let's look at this, see what's changed. Then suddenly you can make on-the-fly decisions that are informed, right, to help out a little bit. And so there's some cool implications for this type of software.
Absolutely. If you're doing quality control checks, to be able to not replace a nozzle too early or too late, both of those are advantageous. So you can really nail down, right, where is that maintenance window that's optimal.
And Kyle, not to get too much into the detail, but this can be quantifiable, right, with the coefficient variation.
Yeah, absolutely.
We can have thresholds that the client can look at and say, hey, at 60%, correlation, and then perhaps there's something that we need to do there. And the economics for each person is going to be different for each application. And you can fine tune that, what your break-even point is and what your risk reward metrics are as well. And this tool is a very economical way to take that out of our lab and push it back out to the clients to be able to leverage and create value.
Absolutely.
Yep. Next slide. So what's neat about this is there are a myriad of applications where we see this being used. Not only is it easy user controls to take what took a lot of sophistication, a highly trained staff, to where now it can be leveraged and used by you. And another piece is on the commercialized side of things. You can notice that we're spraying just a little spray bottle. I'm sure you could imagine with the pandemic and understanding what's going on in that world, spray pattern distribution could make a difference for sanitation, coverage, and those things. Imagine being able to understand the coverage at different distances and that you're receiving. and what that impact might have, not only for your health and safety, but perhaps it's other commercialized products like spray-on deodorant and those things, quality control, quick snapshots. And then the nozzle wear evaluation, we can establish some baseline healthy sprays, and then from there understand what is healthy, what is not, and what is that distinction on when we make a decision. And Kyle, can you speak a bit more on the commercialization side of things as far as being able to take just a handheld sprayer, that process and how simple that is?
Yeah, first I'd like to touch on the wear evaluation, though. I think that's very important that, to highlight that we can establish what a new nozzle will be doing, right? And then using the software, we can have a coefficient of variation that evaluates the similarities, as you see on the right-hand side little movie here, the similarities and differences. And so to take out that evaluation of what's a good nozzle versus a bad nozzle, when are you warm, when are you not, and have a value, an evaluation number that makes that decision for you. It makes it much more consistent. And from the product development standpoint, for consumer products or really anything else, like a spray bottle, shower headers, even developing a process and understanding where the spray is going, it really is a unique tool to be able to evaluate this on site, no matter what the spray is.
Yeah, and I think that instant feedback with not only an R&D and innovation team, but even the spot checks to be able to say, hey, this is quality, right, this is not. There are sprays all over the place. And with this tool, it takes it out of the lab and allows you to have a more certifiable way of assessing sprays.
Yeah, and we've seen the system used both online, in a process, as well as off to the side, sort of for maybe scheduled maintenance checks, but is it really time to replace things or not? Are we late replacing things? Answering those questions.
Sure. Yeah, I like that. Yeah, thanks, Kyle. Next slide. So we're coming up on the conclusion of this this brief webinar, and the major takeaways that we want to empower you with is that spray characterization is important. Rapid insights for quick experimentation is the future. The faster we can get that data and that feedback, the quicker we can make informed decisions. And Kyle, historically, what was the cycle, right? When a client would say, hey, I want to see what this drop size distribution is, how would that time cycle look particularly?
Even just to look at a spray pattern in detail like this, typically we would have a contract day of testing time in our lab. We'd have to send in the materials or the nozzles or mimic the process as best we could in the laboratory, spend a day working on that using these higher end research grade instruments with experienced people, and to move that technology offsite and let you do it on your own very quickly, moving through different setups, different nozzles. All of that has been the real game changer for this system.
Yeah, and from a client-facing end, right? Let's say they have a challenge, there's a big turnaround that's happening. Oh, I need to understand what's happening here. That process, while even if we're moving very quickly, it could take still a few days, couldn't it, Kyle, between all the conversations and getting everything lined up and then scheduling the lab visits and the reporting and all of that.
Yeah, we do our very best, but it's typically at least a few days, if not a few weeks. So it's a very different timeline.
So the time value of money, being able to get that out of the lab into your hands, to be able to get those snapshots and those insights. Again, it's just more optics and more information at your disposal to then make quality decisions. And then the big piece of spray scan is real time and it's in your hands. We're looking at democratizing that information and getting it out to you to be able to leverage and find the insights. We understand the spray process and the spray analysis side, but you understand the application, and that's where we're trying to fuse that gap together. Next slide. So you guys have the chat feature on the far right-hand side. We've got about 6 minutes till the webinar was scheduled to be completed and concluded. Encourage y'all to write any questions that you guys might have, and we'll be happy to answer them, whether it be online or offline. And then what's next? I would say within the next month or so, we're going to have a spray characterization 2.0, where we're going to dive a bit more deeply into applications, the technology, and perhaps how this would be of value for your applications. And the last three pieces is to take a look at our spray analysis and research services on LinkedIn. Connect with us. There we'll just share very insightful research grade technology information as it relates to spray technology. And then two, we do have the spray.com website, sprayscan.com. Then, of course, any questions from Kyle or myself, feel free to email us at sprayanalysis at spray.com. But we really appreciate y'all's time. Dr. Kyle, thanks for joining us on this. It's always fun to get into some of these fun projects. And like I said, feel free to pop in any questions. We'll hang around for the next few minutes. And we hope you guys have a great afternoon, morning, or evening.
See, Deborah has asked a question here. We could probably go ahead with no others. Yeah, no, it's a great question. Where do the smaller droplets exist? That's really going to depend on the spray pattern and nozzle type. Some nozzles end up with smaller droplets out at the edges and the periphery of the spray. Full cone nozzles, that would be more typical. Whereas other sprays, you can have smaller droplets in the center. A hollow cone nozzle, for example, the smaller droplets get pulled in by the air currents and recirculated inside of that hollow cone spray potentially. So it's really dependent. Evaluating the spray pattern alone can be difficult to assess that because the number of droplets and the size of droplets are sort of baked in together. And so for a coating application or for a volume distribution and gas conditioning application, you want to know where the volume of the spray is. You don't necessarily, I mean, the droplet is important, but the volume of the spray and where that's located is important. And so evaluating the pattern like we've shown here will be effective. But if you really want to know if you have a bias in some location across the application of small to large droplets, then testing for drop size specifically would be necessary.
And Kyle, you brought up a valid point. And Deborah, thanks for that question. Too, visually, we can see that that concentration of the spray. Let's say, for example, we see some heavy edges on one side and it's in a gas stream. Imagine the ability to, if you can't replace the nozzle immediately, you can actually rotate that spray to where the bias is beneficial to your process. So that's another granular piece that you can use as a pivot.
Yeah.
We got another question. It says, is this device sensitive to very dense sprays? Yeah, what do you think?
The unequivocal answer there is yes. The laser is illuminating a cross section of the spray, so the laser needs to be able to penetrate through a spray. So if a very dense spray will limit the penetration distance of the laser. Also, because the assessment is based on taking a video of that cross section of the spray. A highly dense spray will limit how much you can see across that spray pattern to visualize that illumination. But the nice thing is it's a very simple assessment. What you see with your eyes is going to be what the video sees when you acquire the data or the images. And so if you can visually see that pattern or the distribution once you put the laser through the spray, then that's what the camera will see, and we can perform the evaluation. So it's a quick assessment, but it is a limitation, and that extends all the way back to the research grade systems as well. So this is a common limitation of the method.
Yeah, thanks for that, Kyle. Well, it looks like we're at that 11:30 mark. Like I said, feel free to reach out to us on LinkedIn, connect with us, and the spray.analysis@spray.com. And Kyle, it's always fun for us to get on these calls together, and I look forward to the next one.
Thanks, Justin.
All right, y'all take care. Bye-bye.